I work for Basho as a CSE, so that's basically client services engineer. Support Riak and Riak CS for EMEA customers. Been using Linux since the 90s, Mac since 2003, Ansible since last year, Vagrant the same, and quite fond of Delft and ceramics in general. Okay, who are Basho? Basho are the creators and developers of Riak and Riak CS. Come from ex-Akami staff, experts in distributed systems, offices across the globe, make their money from professional services and customer support. So who are you? Well, gross generalization is Ansible user. We'll say a proportion of people are. Maybe some of you are curious about Riak. Is anyone actually using Riak? Okay, yeah, a certain amount of people. Good. Vagrant, people using that as well? Excellent, all right. And then we'll add that all together, and it's everyone. The basic requirements for doing this are OS X or Linux. I haven't actually run it on Linux, which is a shame, but it should work. Vagrant, Ansible, VirtualBox. Quick introduction to Riak. I'll try not to bore everyone. It's a key value store. It's written in Erlang. It's got a variety of functionality. 2i, secondary indexing, MapReduce, link walking, Solr search engine integration. It started out as kind of Dynamo clone or equivalent functionality. It's grown enormously since then. Second edition is out pretty soon. It's in active development, and it's going to be pretty good. Quick illustration of how it's structured at its most primitive level. It's a key value store, so keys and values encompassed inside buckets. Buckets are namespace. They have various properties that are applied to data as it's inserted and retrieved. It uses a consistent hashing system, so it hashes the keys, distributes them evenly around a cluster, which is, in our parlance, a ring. Makes replicas of them, gives you data redundancy, and improves throughput. There's a couple of methods that I use for working with Riak locally on my own machine. More Delph. The first is simply to compile it from source. This requires that you, generally speaking, compile your own copy of Erlang, because it's quite specific about the versions. You've got the build tools, compiler, etc. installed. One of the makefile targets is make devrel, and it's got a flag, which is a number of nodes that you want to create. This is very fast when it works. There's a brief overview. You got your OS, you got your 3 Riak instances running. It'll spread the ports that it listens out. So if it generally listens on port 8098, it will put the first one on 10,018, second one on 10,028, third one on 10,038. Stick HA proxy running locally and connect client up to it. Second option is running a Riak VM per instance. It requires quite a bit of RAM, so I tend to only do it with about 3 instances. It can be slower to start a cluster because obviously you're provisioning 3 virtual machines, 3 Linux machines. It's got to download the world. It's fairly realistic in terms of networking, so you can do packet capture, all that stuff on each of the individual machines. And you're also building your cluster on Linux boxes rather than OS X, so it's a more realistic tool chain. It's pretty close to what you'll have in production. This is what it would look like. So you got the host OS, you're running Vagrant, it's running VirtualBox, it's running Linux virtual machines. We've got 3 machines, 3 Riak instances, and there you are on the outside with HA proxy. We've got a configuration file if anyone wants it, and your client, either curl or any one of umpteen languages. Riak CS, and the point of this as well is not to do a sales pitch, but just to illustrate the kind of complexity in setting this stuff up, yeah? So Riak CS is a product that we have as well. It sits on top of Riak, and it provides an S3 type interface. So most of the operations that you can carry out on S3, you can do at Riak CS as well. It's got quite a lot of parts, okay? Uses Riak as the storage engine, and it's got a basic cluster has got, you say, 3-node cluster. You got 3 Riak instances, 3 Riak CS instances, and another thing called stanchion, which serializes certain requests, such as creating buckets, users, that type of thing. Okay, so that's what this would look like. So you're getting into a more complex kind of stack. You can see there are 3 VMs. 2 of them just got Riak and Riak CS. The third one's got stanchion as well sitting there. This is an artist who's currently specializing in Delph as well. Okay, so let's look at deployment. The first stage is simply installing the packages on each machine, applying configuration on each machine, and starting each node. So we go around the ring, and let's say on the first machine, we're installing Riak CS first. Counterintuitively, it must be installed before Riak is installed. We install Riak, we install stanchion, walk around the ring onto the second VM, Riak CS, third VM, the other 2 packages, services. And then for each node in the ring, you then got to walk around the ring and join them together into a cluster. So you, typically, if you're just a standard administrator, you SSH onto each box in turn, run these commands on each one, walking around again. This image is shrunk slightly, but I think it illustrates it. So we look at how we use Ansible and what kind of benefits and advantages it brings to us, and what it is as well, if you're unfamiliar with it. So I might be corrected, but it's open source. It's considered an orchestration engine because you can specify an order that you want things to run in and be very specific about that. So it's not like you've got a client-server model where it checks in or something with a central server randomly. It's also classed as a configuration manager. It's got a variety of functionality for putting configurations onto boxes, templating them, making sure that things are in configuration, removing things from configuration. Software deployer. Obviously, you can also use it to ship software directly onto the boxes from whatever your management node is. And it started on February 2012, so it's relatively young, but seems to be enjoying enormous attention. So what made me interested in Ansible? I didn't want to have to install a client before provisioning a box. I kind of came from the school of just having some kind of script and running it when your machine or virtual machine was provisioned. I didn't like particularly the idea of running a HTTP server as root. Perhaps the alternative configuration managers are running in a different way I'm unaware of, but at least when I was using them, it involved running some kind of client-server setup. It's got minimal syntax. It hasn't invented its own language or used domain-specific language, which, coming from a Scala development environment background for the last couple of years, I've got a little bit tired of. Obviously, I wanted things to occur in a specific sequence. I don't know if it's just me, but I find it easier to debug that way. I like the idea of just using the SSH protocol. Ansible does have some functionality, firewall mode or something, I think it's called. Yeah, yeah. Where you like use 0MQ. Is that still true? It is. Excellent. All right. Okay. So they're moving forward still. Yeah. Excellent. Because I don't really like opening network ports if I can avoid it. I'm a little bit paranoid in that regard. I also like the idea of the push model. Pushing changes to servers is kind of interesting because you can take any server that you're asked to manage. You don't have to really install anything on it except for Puppet, and Puppet? No, Python, whoops. Freudian slip. So why do we use it? Simple to configure and provision, reduces Amazon expenditure. This is speaking about Vagrant. We can quickly deploy new versions onto a local VM, and we can reproduce strange customer configurations. A lot of what we do involves supporting customers and their tickets, replicating their environment if anything goes wrong or it's misconfigured. And another thing we like to do is provision virtual box images for training and demos. We find this quite an easy way to do it. How are we doing on time? Excellent. All right, good. Okay, so let's look through the components of Ansible. Just one sec. Okay, so core to what we're doing is using Ansible Roles. Former employee of Basho, who's now working for Ansible, created a bunch of these roles. So a role is a self-contained reusable module. Can have dependencies upon other roles. I'm not sure if it's transitive, but you can certainly specify everything you need. Similar to chef recipes or Puppet modules, I believe, if that's the terminology kids are using these days. And they have a central repository or clearinghouse for that, which is galaxyansible.com. So you can browse through them, find things of interest, and use them. Okay, so we already covered this. James Martin, he wrote a bunch of them. There's a short URL to get them. They're currently actively developed and maintained by Basho. So there's a couple of us in there. We're keeping them up to date, and we're writing new ones for Riak 2.0. Volunteers are always welcome as well. So this is the basic structure of how they're set up. So we've got a bunch of roles which are up on GitHub. So there's Riak CS, Riak CS packages, Riak stanchion, and Riak common. And they'll provision an entire cluster for you. They make use of a bunch of Ansible modules as well, so that's just base functionalities baked directly into the Ansible product. So there's one for apt, yum, shell, service, mounting directories, you name it. They've umpteen modules and growing. Basic structure of Ansible, at least as far as it relates to us. You've got an inventory file which specifies a bunch of hosts that you want to use it on, the SSH connection parameters, etc. It's really straightforward file. Ansible itself, it's written in Python. You just install it. It's got a bunch of different tools: Ansible Playbook, Ansible Galaxy, Ansible. Reads these things which are called playbooks. Fancy name. It's basically a YAML file, a set of instructions. And reaches out to a bunch of your hosts over SSH and provisions them. Basically, it generates Python executables, puts them up there, and runs them. So super minimal example. This is a tiny little one, best trivial you can do. So in this case, we've said that we want to deploy onto every host. We want it to run under sudo privileges because it's obviously Vagrant, so Vagrant boxes are always going to be sudoed. Same with Ubuntu. It's got one task, add a marker file. It's got a template file there, a Jinja2 template, and it's sticking in etc. marker with root ownerships. Okay, we're going to have to hurry up a little bit, yeah? Okay, this one here is using a role. So in this case, it's Basho Riak common. In this case, it's also adding the marker file, but it'll also install the Riak packages and so on and so forth there. Okay, so quick walkthrough of building a Riak CS cluster. We've got two of these currently written, one for Riak, one for Riak CS. and this is structure or anatomy. So you got your Vagrant file, form cluster YAML, a host file, roles file, directory. Roles text, that gives you a list of all the Ansible roles that you want to use. You can run Ansible Galaxy across that. Against that, it downloads them into the roles directory and set up Riak YAML. Into a Vagrant file, it's nice to have a little snippet like this, which pulls down all the roles if they're not currently available. We get the setup Riak YAML file. It's about as trivial as it gets. It runs on the Riak cluster hosts, use the Basho Riak roles, includes the form cluster YAML file. This is kind of the meat of it. This walks around the cluster, provisions all your different nodes. You can see there, it just goes around, iterates around the ring, does the join, does the create, etc. We got some future goals are to create a reusable set of base boxes. We want to create a Vagrant script for each release of our product. We do have that, but informally, we haven't released it to the public. And we're also looking to create new roles for Ansible 2.0. And a couple of links there. If you want to give it a try out, it's just GitHub. It fits on the slide. Thank you.